it goes back a long way, and as many people will know, it was really led by David Barker, who was working at the time in the MRC unit, where I've been working too. But he was there at the beginning when the unit was really focusing on using routine data. And some of the work that they did early on was mapping of disease, which was quite a new concept then and quite difficult to produce maps 40 years ago. And David had picked up on some other research showing links with maps in the early part of the 20th century, the last century, of infant mortality, and saw how they matched the maps of cardiovascular disease in the later part of the century. But it prompted David, and he really spearheaded this, to try and find data on individuals about things around their early life, and particularly their birth weight and the way they grew and so on. And he set up a number of studies, notably the Hertfordshire Cohort Study, where they identified records from Hertfordshire, which recorded a lot of information about early life and related it to subsequent mortality. And that was quite revolutionary, really, because it showed a link between low birth weight and later coronary heart disease. And that was sort of replicated in a lot of other studies, not just in the UK, but around the world.
Because of the fantastic records that are available in the UK, David sent a bunch of us out looking for them. And, one of the most memorable days for me was finding the Hertfordshire records. I went to the Hertford County Archive and asked this lady, have you got any records? And she said, well, I was supposed to throw them out, but you want to come and see what we've got? I have the county archivist thinks they've been thrown out, but they're in the cellar. So I went down to the cellar, and these big ledgers that all the people in Southampton know about were there. And I just thought, wow.
At the time, it was very strongly that chronic disease like cardiovascular disease, diabetes and so on was entirely caused by how you lived your life as an adult. And there was a lot of skepticism.
David was, having listened to what I had to say, presented me with his own personal problem, which was his early observations. At that time, the MRC was mapping out the relationship between disease and geography. The one thing that I was prepared to do was suspend my disbelief, go away and look at the evidence I could find, and apply Occam's razor and say, well, if all this evidence has to fit into a single argument, what does it look like? And I came back and I said to David, well, I don't know whether or not this works, but at least in principle, it might work. And the challenge now is to see whether or not it does work, and we can find the evidence to draw the relationships. And he was reassured that he had some support, although for most of the country it was still seen as a very bizarre and strange idea. But clearly we started to work together, developing what came to be known as the Barker theory.
Of course, the research has gone from strength to strength then, showing that really what happens, your birth weight is not the key thing, it's how you got to that birth weight. And what happened in the womb, and of course what happens in the womb is how you're nourished by your mother. So we're talking about nutrition in the womb, and I would argue even earlier, how the mother is set up before she even conceives. When David started that work, nobody had heard of the term epigenetics and all the changes that are induced. So it's a whole big field now. But nutrition is at the centre of it.
Epigenetics, it's defined as processes which induce stable changes in the expression of a gene without affecting the gene sequence. So many people have compared genes and epigenetics to a computer, with the genes being the hardware and the epigenetics the software. So essentially these epigenetic processes, they provide the stop and the go signals, so they control the activity of our genes. So there are three main epigenetic processes. These are DNA methylation, histone modification, and non-coding RNAs. But probably we know most about DNA methylation. And what this essentially involves is the addition of a CH3 group, a methyl group, mainly to this cytosine base within DNA. And basically low levels of methylation, particularly across the promoter, the control region of the gene, means that RNA polymerase transcription factors can gain access to the DNA and the gene is then switched on. Whereas high levels of methylation, they prevent RNA polymerase from gaining access to the DNA and the gene is switched off. It's becoming clear that these methylation marks are basically added to our DNA very early on in development. And once they're sort of put on our DNA, they are then maintained. And they are then sort of stable throughout our life. But it's becoming clear that a number of environmental factors can alter these methylation marks. And one environmental factor which has been consistently shown to alter these methylation marks is nutrition.
There's a real role for nutrition in the sort of developmental origins field because it is so key to how the child develops. We're talking about quality of diet, not necessarily specific nutrients, so those are always important, but also inevitably quantity matters too in terms of the underweight and the overweight.
Nutrition can affect these epigenetic processes in a number of ways. So, for instance, one carbon metabolism, which provides the methyl groups for most of these methylation reactions, is largely dependent upon dietary methyl donors and cofactors such as folic acid, vitamin B12, betaine, and choline. These methylation marks are most susceptible to nutritional influences during gestation or during early childhood. And there is a gradual, if you like, tail off as we age. But nobody knew the mechanism, so they didn't know why early life would have such a long-term effect. And there was lots of speculation that early life could actually alter these epigenetic processes. So the idea being that changes in maternal diet could actually affect the availability of methyl groups and affect the establishment of the methylation marks on our DNA. And it could perhaps reset these marks, and once reset, these marks would then be stably maintained, giving rise to long-term changes in the expression of genes, metabolism, physiology, and disease.
It is really the only study in a high-income country that has recruited from the general population from scratch. We really piggybacked on a study in India, the Pune maternal nutrition study, which had really tried to do that in a much more fertile population where babies are largely only had within marriage. So we had to take a very different approach in Southampton. And we recruited 12,500 women, of whom just over 3,000 became pregnant and were part of the study and gave birth within the study. And we're just about to do the 17 to 19-year follow-up of the children. It was a challenge, but it was an enormous privilege to be asked by David Barker himself to run that study. And I really love working on it. A great team, great people, and wonderful participants who've shared so much with us.
In cohorts such as the Southampton Women's Survey, and we've documented that maternal undernutrition, over nutrition, maternal body composition, all of these can actually impact on the methylation of the child. And in fact, some of these marks that are changed by the environment of the mum, these are also predictive, if you like, of the phenotype of the child. And you can use these marks almost to predict the trajectory of adiposity. So potentially these epigenetic marks might be really key to identifying those individuals at increased risk of adiposity, obesity. The latest study that we've done is basically we've been looking at the impact of maternal gestational diabetes on the health of the child. And what we've been able to show is that exposure to maternal gestational diabetes leaves a methylation imprint in that child, and that is associated with an increased risk of adiposity of that child, which then tracks into adolescence and adulthood. But what we were also able to show is that a dietary and exercise intervention in pregnancy was able to markedly attenuate those methylation marks, and that was associated with a decrease in adiposity of the child as well.
Well, I think the impact has been enormous, actually, because I think almost all the major organisations of the world now recognise the early life component as being important. And will talk from preconception through into childhood as being influential. And of course, it's not just nutrition, but as I mentioned before, nutrition is such a major plank of that. And I think it's not just the mother because of those epigenetic factors that I alluded to. I think the father is equally important, though perhaps once the pregnancy is started, less so on an epigenetic front, but I think once the pregnancy started, the whole behaviour influence of the father and the support that he can give the mother is really important. So we've got a whole behavioural side to this. We've got, the marketing, the whole infant feeding issues are really become important.
I don't think there's any doubt that the developmental origins of health and adult disease, which started in Southampton with David Barker, has fundamentally changed the way we think about the biology of growth and development. And it was amazing to be on the ground floor of that. You look at any international discussions, and Lifecourse is part of that now.